Hello, my name is Wyatt Murray. This is my first devlog on this channel. I cover primarily Unity-based programming and other things within the Unity engine as a showcase to both myself for other people to learn and to demonstrate my skill and abilities. So without further ado, let us begin. So I have a sample scene open here with a couple things, but notably our asynchronous loader, which is the focus of today's devlog, is active. I developed this specific loader for asynchronous loading of multiple scenes at a time with or without a fade transition to assist in my studies at school. Um, this comes as a package that comes with the prefab, the script that it runs from, and an icon for the script itself. Um, so with let's get into the breakdown of the actual item itself. So the asynchronous loader is by itself a very in-depth script that handles a lot of asynchronous loading using the scene manager from Unity. I'll start with the prefab, break that down, and then we'll go from there. So the prefab starts as the base parent as just labeled asynchronous loader or async loader. It does not have a tag. It does not have a layer by default. It does not require one in order to function, so you can put it wherever you'd like. Um, it has a couple variables on it that are useful, and it has three major events. It has a any scene loaded, any scene unloaded, and unloading all scenes except persistent. These events are important for if you, for instance, don't know what scene you're loading on, but you need to know when a scene is loaded. I've had a couple reasons for that in one of my past projects where I need to know when a scene is being created or is being brought in and loaded, so that way I may update specific items and scripts around that, as well as unloaded for any reason if you have things that need to shut off when a certain, maybe things that rely on another scene to be loaded, when that other scene gets unloaded, we'll need to notify them that, hey, they should check and reaffirm before they continue with their next call. And then finally, the unloading all scenes except persistent is when a total reload occurs within the async loader, and I'll cover that briefly in a moment, where the every scene that is not marked as persistent will become reloaded. So they will remove all scenes from the hierarchy, and it will reload them all individually. So those are the Unity events, but here are the two structs that I have. So we have a scene name struct. The scene name struct is basically a list. It's rather than a struct, it's a list of structs called scene data. Scene data is simply a is persistent bool and the name of the string, or the string of the name of the scene that you wish to load. And you can have as many of these as you'd like, and you can mark them however you'd like there, and when you name them, they'll rename. So like, let's say sample scene. There you go. So now the element is called sample scene, but it's still a list, so it's considered the 0th place. So um, scene names here just has the scene. If you want to label it persistent, generally I label the scene that has the async loader as persistent, and then I load that scene at the beginning of whatever I'm launching through here. That helps me control my scene flow better and allows me easier movement through the scenes by having a centralized, not singleton, but um, a centralized scene that doesn't have to be constantly loaded and reloaded and unloaded. So that's the scene names. And then after that, we have our fade data. A fade data is basically just, as you can see from the variables here, it is the items that are within the prefab of the samples or of the async loader. And how the fade data works is it's basically just it needs the canvas prefab so that way it can turn off and on the canvas whenever the fading transition is used. And then it needs an image for the actual background of this. So the fade data is not complete as of yet. Eventually, I expect to have a loading bar. It's in my kind of idea sort to kind of tackle, or at least have a public variable of some kind that can be linked to grab that. So fade data has the image, which right now is just this black image. You can change it if you'd like to whatever you'd like there. I just chose it because black fades out really well and it's a nice transition. Um, and this black will stay there until the next scene is loaded. If you wish, there is an overridable method that you can adjust and work through. And we'll come back to that in a bit. So that is the async loader from the inspector. The fade duration, and the fade duration is the duration in float seconds of how long you would like this fade to load out for, well, fade to black and then fade back out into clear or transparent. So it is not the actual time for loading, it is the duration of that fade when it transitions into loading those new things. So without further ado, let's dive into the script. So the async loader is very well, or at least I try to keep it well documented, regioned, and commented for others who wish to do that. I have up briefly up here, I have the author version 2. We're actually on version 3, and the date is no longer 9/20. It is 10/16. So I figured I'd made that, but basically it comes with a brief setup. It has an additional info, and it gives you a brief description so you can look at it at a glance when you go back to the inspector. You can just click here and boom, read all the data that you want there. So diving back into this, I'm just going to close this out here. So we use a variety of namespaces from system collections all the way to the Unity engine events and a little bit of Unity UI in order to balance out that requirement. For using the canvas to render and unrender our fade transition. So to start off with, we have member variables. We have quite a few here. They're grouped together in a what looks to be haphazard way, but they're actually grouped together based on the how they are associated with one another. So our list and fade data are right here, and these have summaries about them, so that way you can hover over them and quickly get um, you can quickly get a nice little tooltip about them when you need to see them. So here's where we have our defined scene data, which is our struct, and that is actually found here. It's just a string and a bool. That's it, and it's public and it's serialized. So anywhere within this script or within scripts that inherit from it, it can be easily used. Fade data is the same thing. Fade data has an image game object for the canvas and a float fade duration, and is serializable as well. So going further down here, we have our list of scene names, which are the defined scene data structs, and then we have a single copy of the fade data, because we only need one for that particular instance. Finally, below we have a public list of scene names, which is just the public version of scene names here. If I open up, it just allows you to pull those names from it, but not change them. So this scene allows for some other scripts to access it for when it needs to gather, say, the list of names for a scene, or if it needs to specifically check if a scene is persistent or not. But outside of that, no other script should have control over this. There's also 3 Unity events that I spoke about earlier, the unloaded, loaded, and unloading all except persistent. Those are found here. I have a private bool called isFading, which determines a couple things inside of the script about where things are and are not fading, so they don't start when they aren't supposed to. I also have a private float and a public float of percent loaded. Percent loaded should be that should not be a set, actually. Percent loaded should only be Q. There we go. So yeah, percent loaded and its private version basically just handle um, what goes in and what goes out of this method. So that way I can tell, for instance, a loading bar, if the loading bar is going to be a the loading bar will rely on, I should say, the loading bar will rely on this number, which will be a number between 0 and 1. To determine its value. And if we need to multiply anything by that, then we can absolutely go for that. Percent loaded actually is still not yet implemented. I'm having some difficulty converting all of the scenes which asynchronously load in their own coroutine together to load all at once, or to load in such a manner that I can easily put the loading bar together for it. But that is a future goal that I wish to have in this project. So going further, we have our monobehavior methods. Monobehavior methods are just the standard methods for monobehavior. In this case, I'm setting the alpha of that image to 0. So it's completely clear upon the first load or first instance of this asynchronous loader prefab coming into play. Next up, we have overridable methods. We have two main methods currently available, and that is the load scene with fade and load scene list. Both of these work together to do kind of the same thing, but obviously with the fade, using a fade transition allows you to do specific things. So fade out and load is the coroutine here, and then this starts another code routine called load scenes. Both of these actually go to the load scenes parameter, and I'll cover that in a moment. And they load scenes is just depending on, or it depends on where the load scenes coroutine is started. So here we go. So this is the 4 coroutines, and actually that's not a coroutine, but it's a set. Um, yeah, we'll move that out in a moment. I think that's actually going to be in miscellaneous code down here. I think I just moved it over so that way it would be in the fade area, so that way it would work better. Here we go. So I'll close back this miscellaneous code here. I know the spelling's atrocious. Please do not mind me. So in the coroutines, we have 3 private coroutines: load scenes, fade out and load, and just fade. And this is basically the gradient that you have to choose from at this time. Is you have load scenes, which just takes the scene list, loads all of them, and then if you decide to unload, for instance, all of your things, this will be called unload all scenes except persistent is its own little thing down here. And at the end, let me see if I can find it. At the end of this method, it calls the invoke right there. Yep. So unloads all scenes except persistent will invoke its thing once, or it will invoke its Unity event once it is done unloading all of the scenes that has been listed. The reason I put this as I put the invoke after all the things have finished is because often code will execute as needed up until the point it is no longer required. And in this case, I want to keep those scenes in the at least in where other code will be relying on them. Once that begins, they will shut themselves down. I actually probably could migrate it up to above, invoke the scenes here now that I think about it. If I call this here, oh yes, for the things that are not persistent. I guess I'll do that then. That way it unloads everything and then gets called all at once. Or, well no, we want to call that before, so I guess there will be where that goes. Okay, I apologize for the modifications of my code while I'm explaining it. We'll get back to this now. So, load scenes does an asynchronous load. It calls the load sync and await for completion coroutine. It yield returns, so basically it just waits till that's done and then will then come back and start the line after this, which is in this case the end of the for each loop, so it starts again. So here we go. The next coroutine that we have available is the fade out and load. And the fade out and load actually uses the fade coroutine below and the load scenes to do a combination of the two. So this basically turns on the canvas, sets that it is going to be fading and transitioning. So other script or other parts of the script know that they cannot do an additional action. It starts the coroutine for the fade, so it starts to fade out. Once that is done, it'll run the load scenes method, or the load scenes coroutine, where it will then load all the scenes that we've requested it, and then we'll give it all the data it requires. And then finally, once that is done, we'll load back in and fade back in, and then we'll turn off our fading, and we'll turn off the canvas as well, because we no longer need it. So that is the fade out and load. And then finally, we have our fade coroutine The fade coroutine uses a method called setFadeAlpha to basically determining based on the float value of something, it's going to change a image's alpha color or alpha value for their transparency. Um, it is right here. Yep. So if the fade data image is not equal to null, we're going to set the color um, alpha to the alpha and then set the color to the color, or set the color back to what it is. So we pull it, change it, and then push it back in. All right. So that is the list of coroutines that we have here. And then finally we have our miscellaneous code, which I've been referring to. This is primarily the unload all scenes except persistent method. Another coroutine called load scene async and wait for completion. It's technically not a coroutine that I want to pair with the others due to why it's in this region. So it is in this region because it is a smaller part of a greater whole of a method, and so I consider that to be a miscellaneous utility rather than a required part of this method, even though it is the um, heart and soul of this entire loader, because it uses the load scene async scene manager call and then waits till it's done, and then after that it'll call its unity event, the ims or scene loaded event there. So every time that a scene gets loaded, so you might have 6 or 7 of these calls in within a 2 or 1 or 2 second period if you have a small scene. Um, and basically, it's just going to go out for anything that requires that. It's going to be called in due time. I'm working on a all finished Unity event for when all of the events are done loading, but as I have not finished the um, percent loaded, I have not finished that as well. Those two will go hand in hand, and hopefully will look very nice together and work well in tandem. And then finally, we have the setFadeAlpha, which I covered before, and that is our miscellaneous code for, or the miscellaneous stuff for our code execution. This is my async loader. It's been quite some time since I started this project, and I've really enjoyed I've really enjoyed and taken a liking to handling this in a very object-oriented way, and it's not specifically a game design kind of project, but it allows me to explore some things that um, I'm not super good at, and I don't have a lot of an understanding behind it. This took a lot of research for understanding how coroutines work and learning what iterators are, yields are, why we should yield a return null for certain things, um, how the IE enumerable system works and that type in that interface, as well as the actual type IE enumerator or IE enumerable. Um, and hopefully, uh, this will be in more use by other people, and I can share it with my friends, and hopefully we'll all find good use out of this script as it continues to get updated. This is as I briefly changed, we are now on version 3. The first version was just the load scenes. The second version added in a fade transition, and this current update here, which is version 3.0, is our new and improved code base that's well organized, uses fade transitions, can also load things independently, and is much more condensed and readable, even if some of the coroutines look like this. Also, all of the objects in here have summaries, and if they have parameters, they're given parameters and explanations of them as well. I'm still learning how to type parameters and summaries here, but I've made sure to give every single thing that needs it, where it could be called either inside of the script or outside of the script, a summary and parameters, so that way it can be listed there, as well as all of the overridable methods, which also have their own summary and parameters. All right, well, that is all for my demonstration and devlog. This is my first devlog on a project that I already have a couple iterations in. But here we are. Thank you so much for watching, and I hope to be sharing a lot more information with you and showing off my skills. Thank you. Have a great day.